welcome to my math teaching channel online again today. Today I'm so exciting to show you another video about the derivative in motion of an object. And I think this is my last video for the first course one introduction to calculus course. And I'm so excited to let you know that after 3 months, almost 3 months of developing my first course online to serve our public education, I am thrilled to announce that I have done the course developed, and today I would like to share with you one thing about the derivative in motion of an object. So this is the PowerPoint I made for the course online, which is I found it pretty. I don't know, maybe I'm biased, but I like it. So I would like to talk about the derivative in motion of an object. Now, we have any object, let's say a particle travels on a straight line or on a curve, and any object in our universe have its initial position. Then when height changes, the object may move, the object can move to another position, and this in physics we call the displacement of the object. Now in this video I would like to show you the connection between the physics formula and calculus formula. And actually I think the calculus formula is derived from the physics formula. So that's the first thing I would like to talk about. Second is derivative of a position function is a rate of change of an object due to its motion. It is also a velocity function. So the velocity function actually is a derivative of the position function. So when you take derivative of the position function as respect to t, to time, it's become a velocity function. And then your velocity can change during the times, over the times. Like it can go increasing, your velocity can be increasing or decreasing, depend on when you ride the car, you can speed up or you can slow down. So the rate of change of the velocity is a derivative of a velocity function, and it costs, when you increase your speed, we call it acceleration, and when you decrease your speed, we call it deceleration. So the derivative of a velocity function turn out to be an acceleration. And you know, like in our universe, like we're talking about like the atoms from the discovery from Newton. He questioned why the atom is not going up to the sky, but it fall down to the ground. And he reasoning after discover about that observation, he came up with the acceleration, which is every object in the earth it fall down due to the force of gravity, which is the force in the center of the earth, pull down the object. And so therefore we have a acceleration number, which already calculated by the mathematician and scientists, which is 9.8 meter per second square, which is the force of gravity applied to any object in the earth due to their motion. So anyway, I am going to go to the next slide for you to see. So here I show you how to derive the formula of the position function in calculus. So we know that in common sense, we know that to calculate the distance of your driving, you use the average velocity time with the change in time. So that's the basic concept. When you ride a car and your speed average velocity of your speed is 80 kilometers an hour. If you drive in 1 hour, you multiply with an hour. If you drive in 2 hours, you multiply with 2 hours. So the formula basic is your average velocity multiplied with the time. And therefore, it's also derived by distance equal VI plus VF divided by 2, where VI is the initial velocity, adding with final velocity VF and divide by 2. So doing that, you get the average velocity. So if you ride with the high speed, but then you slow down, you will add with the final velocity of your speed decreasing, and you divide by half. So you in general, you take the average velocity, you time with the time, and that is how you calculate your distance. Now, when we're talking about the distance respect to the time, we put in the formula VI plus VF. But how do you know your VF? Your VF based on your initial velocity adding with your acceleration time with the time when you speed up. So the VF here will be substituted by VI plus your acceleration time with time. So this VF is actually the same like your first initial velocity adding with the acceleration multiplied with the time and divided by 2, time with the delta t, the change in time. So when you simplify this equation, you get to the third equation, and this is in physics formula. Distance respect to time equal initial velocity time with the time of your driving, because you multiply VI here with the t here. And adding with this one is 1/2 of it. The reason because you add 2 VI and you divide by 2. So you come up with 1 VI only here. And for your A time with t, your acceleration multiplied with the time here, you have to divide it by half. So you put 1/2 in front of it and you time with A times t, but you also multiply with the t outside here. So it becomes AT squared. So that is your distance formula in physics. Now, when it comes to calculus, we call this dt is the displacement position, which is we call this is the s respect to t. S is the displacement position equal the initial displacement. So let's say if you let's say if you have a calculator, right? And the height from your calculator to the route is 1 meter or 2 meter, right? Let's say 2 meter. And from that, you drop your objects. Your calculator will travel a distance from this initial position. So this we call initial position DI. So it could be 2 meter or 1 meter or 100 centimeter, right? Whatever unit you want to use it. Usually in meter and per second, right? So that is start from your displacement, adding with this VI times T here, the physics formula. And 1/2 of the acceleration, which is due to the force of gravity when the object falls down, which is you divide 9.8 divided by 2, you got the number 4.9 time with t squared. And this is the position formula in calculus. So in this short video, I just would like to introduce you the relation and how it logical connect between the physics formula and the calculus formula. So when it go to the next slide, I just want student to remember the position respect to time, the position function, with respect to time. And when you derivative of s prime of t, which is we were explaining about the derivative in previous video, and your derivative of the initial position will become your velocity function. And then when you take the derivative of your velocity function again, you come up with the acceleration function, because the rate of change of your velocity is your acceleration, whether you accelerate up or you decelerate your speed going down. So when you take the derivative of your velocity, you change the velocity function become an acceleration function. So that's how derivative work in the motion of any object. So basically, the s prime t is the rate of change of a position function, and v prime t is the rate of change of velocity, causing the acceleration or deceleration to occur. So that is how I explain about this slide, these 3 slides in my PowerPoint. This is just the more, like adding additional clarification about derivative in motion to my first introduction to calculus course. So thank you for watching. I hope you enjoy, and I will progress through the next video, which is introduction to my first calculus course that I spend almost every 10 hours a day and in almost 3 months to develop my course. Now, maybe because I'm not a fast person, or maybe because I'm still doing learning, working and learning at the same time for the teaching online. So bear with me and please be patient if I slow. But however, I have done my first course online to serve all of you in YouTube, as well as whoever registered to my course online. and I'm really happy and exciting to share with you. Um, this course were done with a lot of my, like, lots of my effort, tremendous efforts to put into it, my time, my energy, and I try to make a very good course. I try to reconnect them in the ideas in the course and the sequence in the course in a logical way, and connect them one by one together, so that it flow smoothly, I think. And so I take time to research. I take time to choose what homework I should offer you, how I should do the quiz, how should I explain the concept with the logical sequence step, follow the natural order of the mathematics universal language. So I hope all of my effort and my hard work will be paid off, um, because if you are taking my course and you interested in the the subject, um, you will find it's fascinating and interesting. I hope that it contribute to our knowledge, and um, I hope you enjoy. That's all I hope for. So thank you very much for watching, and I will see you in the next video to talk about my first introduction to calculus course. I haven't published it yet, but it will be published soon. So bye for now.